been bothering you. I'm going to fix this. I was thinking gradient. And I did the same thing down here. We don't have an I and a J on our function f. And the thing that caused me to realize that something was amiss is that what I was going to get here was going to be a vector and not a value, but we're trying to maximize the value of f. And I gave you a vector function. So this function was xi. Well, I'm trying to do it again. I want to write an I and a j component. It's x plus y squared. So f of xy is x plus y squared. When I took the gradient of f, it wouldn't be possible to take the gradient of a vector function. So if I'd have done this carefully, I would have realized right away that I was doing something impossible. In any case, okay. So really our f of xy function should be x plus y squared. Our g of x function, x squared plus y squared minus 4, just as I wrote it. Okay. Now everything follows because the gradient of this is I plus 2yj, so everything I've done here is correct. If I plug in 1/2 square root of 15 halves, y squared is going to be 15 fourths, x is going to be 1/2, so we're going to get 1/2 plus 15 fourths. Now I'll work that out in a minute, but let's see what happens if I do 1/2 negative 15 fourths. I get f of 1/2 negative square root of 15 halves. What's that equal? Well, again, that equals 1/2 plus 15 fourths. Okay? So, well, I can add this. 1/2 is 4 fourths, so our result is 19 fourths both times. Now this could mean one of two things. We could have an inflection point here so that 19 fourths is neither a maximum nor a minimum. Or 19 fourths could be a maximum for the function, and that maximum would occur at both of these points, at 1/2 square root of 15 halves, 1/2 negative square root of 15 halves. To determine whether this is a maximum or a minimum, there are more sophisticated methods, but let's just think 1/2 square root of 15 halves. The square root of 15 halves is pretty close to the square root of 16 halves, which would be 2. If y is 2, then x is 0. Okay, so the point 0, 2 is not all that close to 1/2 square root of 15 halves, but maybe close enough. So let's just evaluate f at 0, 2 and see what we get. If we get something more than 19 fourths, then we're pretty sure that 19 fourths is going to be a minimum value. If we get something less than 19 fourths, then we're pretty sure that 19 fourths is a maximum value. So let's see. F of 0, 2 equals what? Well, it's 0 plus 2 squared, which is 4. Okay, is 4 greater than 19 fourths or less than 19 fourths? Well, 16 fourths would be 4, so that this is less than 19 fourths. So 19 fourths should be a maximum because there are points in the curve where the value is less than 19 fourths. And that occurs at both of these points. Now, we don't have a lot of room to draw it, but if we draw a circle of radius 4 about the origin, so we can put an x and a y axis on here, where are these points? Well, x is 2 here, y is 2 here, x is 1/2 all the way over here. So the point 1/2 square root of 15/2 would be here. And the point 1/2 negative square root of 15/2 would be here. This tells you that as you move around this circle, sometimes the f of x, y function is increasing, sometimes it's decreasing. This point is pretty close to the point 0, 2. Evaluating at 0, 2, we find that the value of the function is less than it is here. So this means that the function is probably decreasing as we move from here to here. Now, because of symmetries in the y direction, okay, both of these functions are symmetric with respect to the x-axis, because if we replace y by negative y, neither of these functions changes. So by the symmetry, whatever happens as we move through this point going this way is what happens as we move through this point going this way. Okay, so move away from the x-axis, go through this point, we get the same values we get if we move away from the x-axis going through this point. This tells us that the function is decreasing from this point, okay, to some other point. Well, if it's decreasing, it really ought to have a minimum over here somewhere, shouldn't it? Okay, so does this make sense? Here, the value of the function is 19/4, that's 4.75. Here, the value of the function is 4. So the function decreases from here to here, but then it has to come back up to a maximum here. But then it decreases as you move along here. Is there something that we missed in this analysis? Is there a critical point that we somehow failed to find? So we're going to want to look at that, because we do want to look at what happens. We want to think about what this model is telling us. It tells us we have two maxima that are clearly maxima, but no minima. Okay, well, what could be missing? How can we patch this up?